All right, today we are diving into something huge. We're talking about a blueprint for building communities that are completely self-sufficient. I mean, generating your own power, running your own internet, the whole shebang. It's about creating a sustainable, independent future from the ground up. So let's dive in and see how this thing actually works. So, picture this. Imagine a town that isn't just a bunch of buildings, but a single living, breathing organism. A place where the power grid, the data network, and even the local economy are all woven together to be super resilient without having to depend on these fragile, faraway systems we all use now. And listen, this isn't just some nice thought experiment. It's a real engineering challenge.
So that really is the big question, isn't it? What if the exact same system that keeps your lights on is also hosting your local cloud, locking down your data, and fueling your local businesses? That's the idea we're digging into. And honestly, it completely flips the script on how we think about basic infrastructure. Now, I know what you might be thinking. This sounds like it's straight out of a sci-fi movie. But what we're actually looking at is a super detailed, totally actionable plan. It's a vision for what they call a sovereign future. And it's built on a concept called the sovereign stack. The sovereign stack, it's not just a pile of hardware. Think of it more like the entire playbook. It mashes up the physical world, power plants and grids, with the digital world of servers and networks. And then it wraps this whole new layer of economics and community rules around it. It is, quite literally, the blueprint for independence. And this right here really paints the full picture. You see the RIOS campus at the heart of it all. That's the physical infrastructure. That's connected by RIOS Mobile, which makes sure the connection is always on no matter what. But here's the kicker, the thing that makes it a real ecosystem, the human element, the training and the skills needed to actually run it. So it's not just about cool tech, it's about making tech and people work together seamlessly. Okay, so how on earth do you connect two totally different worlds, like power and data? Well, the entire concept really hangs on this one simple, but honestly brilliant idea that the designers called the Velcro principle. Just think about it like actual Velcro, right? You've got two different sides. One side is your power generation, the generators, the solar panels, whatever. The other side is your data center, all the servers and switches. Now, on their own, they're useful for sure. But when you physically and, get this, thermodynamically lock them together, they create this incredibly powerful, unified system. And check this out. This diagram shows you exactly how it works in a perfect loop. The power generation runs the data center, but the data center's waste heat, it doesn't just get blown out into the air. No way. It gets captured to do things like heat a greenhouse. Then, get this, the byproducts from the greenhouse can be used to fuel the power generator. It's a perfect circle, a closed loop where literally nothing goes to waste. And this quote, this is the philosophy that drives the whole model. Waste heat is just misplaced energy. Every single byproduct, everything we'd normally call waste, is seen as a valuable resource. So the heat coming off of a server isn't a problem you need to solve with a bigger fan. It's an asset you can use to distill water or grow food. It's a total shift in thinking. This chart really puts it side by side. On the left, you've got our current model, centralized, super fragile, and pretty wasteful. On the right, you have the sovereign stack, decentralized, resilient, and circular. It's a world where energy isn't just used up, it's recycled. Where your data isn't sitting in some remote server farm, it's local and it's secure. Okay, so who in the world is qualified to design and run a system this complex? I mean, this is not a job for your average IT guy or a power plant operator. No, this requires a totally new kind of professional. They call them the master of the ecosystem. And this person, this leader, has to wear 3 different hats, all at the same time. They need to think like an engineer to build the physical system, like a banker to make sure it's actually profitable, and like a mayor to govern the community that depends on it. So let's break that down. First, you got the engineer. Their job is to design the physical fortress that houses the power and data. Then there's the banker, who has to master all the economics to make sure this whole thing turns a profit. And finally, you have the mayor, who drafts the rules, the digital constitution for the whole community. And this infographic just nails it. It ties everything together so well. You can see the physical stuff up in the top left, the economic model right below it, and then the governance, what they call the human operating system over on the right. One person, the sovereign systems architect, has to be an expert in all 3. Incredible.
So what does this architect actually do all day? How do they make those critical decisions that keep this whole ecosystem running and, this is key, profitable? Let's get into the nitty-gritty of the blueprint.
Okay, the secret weapon in the architect's financial toolkit is this thing called the spark spread. Now, this isn't just about making power, it's about playing the market. It's a constant, real-time calculation to figure out the absolute most profitable way to use every single kilowatt of energy the system produces.
And that big calculation really boils down to one crucial decision they have to make, moment by moment. Is it more profitable right now to use the synthetic gas or syngas they produce to power the data centers, or should they turn that gas into liquid fuel and just sell it? Or is the smartest move to store that energy in batteries and sell it back to the main grid when prices are highest? And those are the three main levers the architect gets to pull. They can sell computing power, they can sell actual physical fuel, or they can play the energy markets by storing and selling power at just the right time. Being a master of this spark spread is what turns this whole thing from just a piece of infrastructure into a real profit-making engine. So, the grand finale of all this hard work, the engineering, the economics, the governance, is a master plan. It's this incredibly detailed blueprint for a real-world site, bringing together power, data, and even agriculture into one amazing, cohesive design. So, the big question is, how does somebody actually become a sovereign systems architect? Yeah, you can't exactly go get this degree at your local university. This is the absolute peak of a very specialized training program. The architect certification is basically the masterclass at a place called the Dereticular Academy, and it assumes you already know your stuff. You've got to come in with skills either as a certified network administrator or a power systems technician. This class is where you learn to fuse those two different worlds into one functioning whole.
And the final exam? It is intense. It's called the Capstone Defense. Candidates get a real-world problem, like, say, a disaster relief camp or a remote farm, and they have to design a complete master plan, totally from scratch. If they can successfully defend that plan, they earn the Black Badge, which means they are officially a certified architect. And look, this isn't just a theory. Here's the actual pricing for the certification courses. And you can see who it's for. The target audience isn't just hobbyists messing around. It's for civil engineers, serious investors, and government leaders who want to build truly resilient communities. This is a pro-level certification for a brand new profession. Which brings us to their tagline, and it's just the perfect way to wrap this all up. Don't just survive the future, blueprint it. The whole idea here is about taking control, about moving from being just a passive consumer of services to being the active designer of your own community's future. And that kind of leaves us with one last question, doesn't it? What kind of future would you blueprint?